Good day. So far, we have been using the measurement of 360 degrees to denote the angle for one complete revolution. However, this value is arbitrary, and in some branches of mathematics, angular measure cannot be conveniently done in degrees. Hence, a new unit called the radian is introduced to describe the magnitude of an angle. Let us now turn to page 6 of your notes to see the relationship between the arc length, the radius, and the angle that is subtended at the center of the circle. In the earlier part of the SLS module, you would have seen visually how the radius, the arc, and the angle in the center is actually related in radians. In general, the angle theta in radians is subtended at the center of the circle with radius r and by the arc AB in this case or PQ in this case. We see that if the radius is r and the arc is also the same length, also r, we can say that this angle here essentially is 1 radian. So by formula, the theta measured in radians is just the arc over the radius. And because we say that the angles in the center in radian, represented by theta in this case, if theta is the arc length over the radius, we can see that the arc length, if I don't have an arc, but instead I have the full circle, 2 pi r, the circumference. Alright, and if we have my radius, in this case r, so I'm going to call it r as well, we know that if one full circle, one full circle gives you 2 pi r, one full circle's angle in degrees is actually 360. We know that 360 degrees essentially is 2 pi. Therefore, we will then see that 180 degrees essentially is represented by pi radian. And this brings me to page 7, where the conclusion there states that when an arc PQ is 2 pi r, meaning the PQ essentially is the circumference, it means that the arm OP has made one complete revolution. OP has moved through an angle of 360 degrees, and that's how we concluded that pi radian is actually equals to 180 degrees. Let us pause and do some conversion practice before we go into word problems. Now let's try to convert the following. 1 degree to radian mode. Now, if 180 degrees is equals to pi radian, alright, we will therefore know that 1 degree is as good as 1 over 180 degree times pi. So 1 degree actually, by calculation, is 0.01745. Oops, let me do this again. 17453, so on and so forth, is an irrational number. And in 3 significant figure, we will have 0.0175 radian in 3SF. The other way, if I have 1 radian and I want it to convert into degree, we will know that pi radian is actually 180 degrees. Now, if you remember pi, you can see as the number, pi is about 3.141 something, 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 something. So your pi, alright, can be seen as a number. So to find one radian, therefore, is as good as taking 1 radian out of the pi radian times 180 degree. And that, upon calculation, will give you 57.2957, so on and so forth, to give you 57.3 degrees in 3SF. Now that we know what is 1 degree in radian and what is 1 radian in degree, let us convert various types of degrees into its radian measure. Now, first example we have over there is 45 degrees. If I want to convert 45 degrees into radian mode, I know again 180 degree is actually pi radian. So to calculate only 45 degrees, I take 45 degrees out of the 180 degree, I multiply by pi. And this will give me 0.78539 dot dot dot, and in rounded off to 3SF, I get 0.785 radian. The other one, it's 114.5 degrees. Well, still not more than 1 pi radian, because 1 pi radian is 180 degrees. So let's check out what we have. If 180 degrees is equals to pi radian, all right, 114.5 degree essentially is 114.5 out of the 180 degrees multiplied by my pi. And this will fetch me 1.9984, so on and so forth. Well, almost 2 radians when rounded off to 3 significant figure. If you can convert degree to radian, I'm sure you can do the opposite, which is to convert the radian into degree now. Now we know that 1 pi radian is equals to 180 degree. If you look at this number here, 9/4 pi, essentially is, if I do a quick calculation or re-express this 9/4, it is actually 8 1/4 pi. Alright, so you will expect it to be larger than 180 degrees because it's more than 1 pi radian. So for this case, if I do my conversion, I know that pi radian is equals to 180 degrees. Therefore, 9/4 pi radian, all I did was take my pi radian and multiply by 9/4. So I'm going to take my 180 degree, also multiply by 9/4 to give me 405 degrees exactly. Similarly, pi radian is equal to 180 degree. Now I have 4.25 radian. Now think of the number pi. The number pi is 3.1 something 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 something. All right, that whole irrational number you have there. So this is 4.25 radian. Do you think it will be more than 180 degrees? I'm sure you agree with me that it is more than 180 degrees. So if pi radian is 180 degrees, 4.25 radian, when converted, will be your 4.25 divided by your pi times 180 degree, and that will give me 243.507, so on and so forth. In 3SF, I will get 244 degree. Yes, more than 180 degrees in fact. To be able to do conversion is important because at the time in exam, say you have a brain lag, you actually forgot what radian is all about. At least if you know the conversion, all right, you can choose to do the answers or do the workings of the circular measure questions in degrees and then later convert back to radian or vice versa. So this is a skill set that you need to know. Let us go back to the SLS module and complete the rest of the chapter.